heap sort is one of the sorting techniques which is based on heap tree, right. So, heap sort is a comparison based sorting technique based on binary heap data structure. Okay. If you see, if I construct a max heap 14, 7, 13, I have some 5. This is, let us take a small case. What will be my array structure? Array structure will be something like this: 14, 7, then 13 and then 5, index 0, 1, 2, 3. Okay. The logic is delete the maximum element. The logic of heap sort is simple. Delete, which element can we delete in heap sort? Only the root element. Delete 14. After deleting 14, okay, you will be deleting 14. After that, what you have to put here? The last element should come into the first location. So, 5 comes here. So, this 14 has gone, 5 comes here, right. 5 is shifted here, you place 14 here, you place 14 at the last location. Now, this is gone. You do the heapifying process. Does it require heapifying? Yes, because it is not in max heap order. You have to do heapify here. How to do heapify? Compare 5 and 7, 7 is greater than. Compare 7 and 13, 13 is greater. Swap 5 and 13. So, 13 comes here and comes here 5. 13 comes here and comes 5. Now, again after this, delete the root and bring the last element, that is at location 5, because that is the last element. No, this is the last element, this you have to bring it to the root. So, you have to delete 13, 13 is gone now, whatever is the last element 5, that you bring it here and place 13 at the end, place 13 at the end. Now, the tree becomes something like this, 5, and this is also gone now. Now, again do heapifying process. Okay. So, when you do heapifying, you will compare this and you will bring your 7 here and you can bring here 5 here. Now, delete max. So, delete 7. When you delete 7, what you have to do? Bring the last element to the first location. So, when you delete 7, this was 7, 5, no. Now, when you are deleting 7, bring the last element 5 to this location and take 7 here. So, this element becomes only 5. Now, any heapifying required? Not required. That is it. See, you get the sorting array here, 5, 7, 13, 14. Okay. Let me explain the same with a bigger example. Let us take 14, 7, 9, 2, 1, maybe here some 7, oh sorry, let us take 8. Okay. This is satisfying the max heap property. So, in my array I will have the elements 14, 7, 9, 2, 1, 8, indexing 0, 1, 2, 3, 4, 5. This is my max heap array representation. What you have to do? Delete the root. Root gets deleted. Copy this into a separate element. Let that be in I have copied that into separate element 14. Then, what is the logic of deletion? We have studied in deletion what we are doing? Copy the first element into some variable, copy the last element into the first element location. So, copy the last element into first location. So, 8 is deleted, kept here. Okay. Then place the 14 here. Okay. Now, what happened? 8 came here and this is deleted. Does this requires a heap? Is this satisfying a max heap property? No. Do heapifying process. First step delete, second step heapify. Okay. So, how do I heapify? Compare 8 and 7, 8 is large, compare 8 and 9, 9 is large, swap these two, 9 comes here and 8 goes here. Okay. So, in that way 9 comes here and 8 comes here. Now, is it satisfying heap property? Is this satisfying? Yes, that is it, over. Again go back and delete the root element. So, 9 I have to delete, 9 I will copy that into my CP variable. Okay. Now, whatever is there in the last position, that is 1, that you bring it and keep it in the first position. 1 comes here, this box is empty now. Okay. So, 9 is gone, 1 comes here, this is deleted now. Okay. Place that 9 here, that location, but we are maintaining a counter, right. Now, we are in this case we are maintaining a counter. So, what you have to do now? Is this tree satisfying the heap property? No, it is not satisfying the heap property. We have to do heapifying process. How to do heapifying process? Compare 1 and 7. 7 is large. Compare 7 and 8. 8 is large. Swap this 8 with this 1. So, 8 comes here and 1 comes here. Okay. So, what will happen here? 8 will come here and 1 is replaced here, right. Now, when you get 8 and 1 like this, is it heapifying? Yes, it is already in sorted order. Now, again delete the topmost element, So, I am copying that into a variable CP, this I am deleting, and what is there in the last location 2, that you bring it to the root. So, this gets deleted now, 8 goes away, 2 comes here and this is deleted. So, I will place 8 here. This is my counter now. Now, does it require heapifying? Yes. Compare 2 and 7. 7 is large. Compare 7 and 1. 7 is large. Swap this 7 and 2. So, my array I am swapping here 7 and 2. Now, delete the max. So, 7 I am deleting. I am putting that in a copy variable 7 here, right. So, and bringing the last element into the root locations. 1 comes here and 7 gets inserted here. So, this is my array only. So, here 1 comes here and this is not there now. Now, do heapifying process. When you do heapifying process, 1 comes here and 2 goes here, right. So, 2 comes here and 1 here, 1 here. Now, delete max, delete the root. So, I will copy that into a CP variable, this gets deleted and the last most element I have to bring it to the root. So, only one element is left, that I have to bring it here and place 2, right. You deleted this and you got 1 here, this is gone, that is it, you reach the last element. So, this you see 1, 2, 7, 8, 9, 14, this is the logic of heap sort. Okay. In max heap, you are deleting the root element, okay. You are taking the last element, placing it in the place of root element, and you are doing heapifying. Again delete the root element, place the last element in the array to the root element, swap it, do heapifying process. Keep repeating this, you will have an array which is in sorted order. Okay. This is one technique which is based on heap data structure, right. This is based on heap data structure. Okay. Let us see details about this heap sort. It is a comparison based sorting technique based on binary heap data structure, right. It can be seen as an optimization of selection sort, okay, optimization version of selection sort, where we find the max element and swap it with the last. Okay. We repeat the same process, right. The time complexity is better here, instead of order of n in selection sort, it is n log n only, right. Heap sort algorithm. First rearrange the elements so that they form a max heap. If the elements are not in max heap format, first convert those elements into max heap format. After that, repeat the following step. What is that? Swap the root element with the last element of the heap. Swap the root element with the last element. Then remove the last element of the heap. Okay, remove the last element of the heap and heapify the remaining elements. Keep repeating this process. Repeat these 3 steps continuously. Delete the topmost element, place it at the last location, bring the last element to the root location, then heapify it. Again delete the topmost element, keep it in the last place and again heapify it. Keep doing this process, ultimately you will be getting us the heap sort, the sorted array will be, or sorted elements we get in the array format. Let us see an example here. Okay. So, an array is given here 9, 4, 3, 8, 10, 2, 5. Okay. This is the structure given to us. You can see the array representation here. So, the first step, if the given array is not in max heap format, we have to convert that into max heap. How do you convert max heap? How to convert max heap, right? So, first you compare each node with its children, ensuring that parent nodes are larger than. So, compare 2 and 5 with 3. So, compare 2 and 3 satisfied, 5 and 3 not satisfied. So, what you have to do? You have to bring 5 here and 3 here. This case 4 and 8 not satisfied. So, 8 will come here, 4 will come here. 8 and 10 not satisfied. So, 10 will come here, right, 10 will come here and 8 will come here. This is at low level. So, when you do these operations, see this will be your 8, 10, 4, 3, you will swap it. So, you are swapping 4 and 10, same way you will be swapping the 5 and 3. See, I am swapping now 5 and 3. So, the tree becomes 10, 8, 4, 5, 2, 3. Okay, we are swapping it with the elements. How we are doing this? See, I am trying to find out 4 and 8, which is large 8, 8 and 10, which is large 10, swap these two, that is it. 3 and 2, which is large 3, 3 and 5, which is large 5, swap these two. Okay. So, I am trying to construct a max heap. So, here I got a little. Now, again compare 10,
You have 5 minutes remaining.
9 with 10, compare 9 with 10, okay, 10 is large, 10 and 5, 10 is large, swap these two. So, the tree becomes like this. Okay. After swapping, I get that this is my final tree, 10, 9, 5, 8, 4, 2, 3. I constructed a max heap now. After constructing max heap, what we have to do? Delete the topmost element. So, this is the tree, we have to delete the topmost element, 10 you delete it. After that, the last element of the tree should be placed onto the root. So, it becomes like this, and place 10 here. Just to swap the last element with the root element. So, the tree becomes like this. Now, this is not there in your area logic. Now, you do heapifying for this, root. So, you swap these two, you swap these two, right. Somehow you will heapify that. Okay. You got this 9 here, see 10, 5, 3, 4, 2. This is your tree. This is in proper max heap order. Again delete 9, swap it with 2, because 2 is the last element. Delete 9, so 9 becomes here, 10 becomes. So, 10 is also gone now, 9 and 10 are gone. So, this is your tree. Again heapify this. Okay. Again heapify this tree, 2 and 8, 2 and 5. You keep doing heapifying, you get the 2 as the last element, something like this. You get 2 here. Okay. Now, this tree 8, 4, 5, 3, 2 are in nice order, max heap order. Now, what we have to do? Delete the root element, swap it with the smallest element, swap these two, the root and the smallest element. So, 8 comes here, 2 goes there. So, this is my leftover tree now. Do heapify process for this. Once you do heapify process for this, so you get 5, no, you will compare these two, 5 and 2. So, this side is 4, this side is 2 and this side is my 3. Now, what you have to do? Swap it with the topmost element, swap these two. So, 3 comes here and 5 anyhow is deleted now. Now, again you do heapifying process, then with this 4 comes here and 3 comes here. So, 4 gets deleted slowly, 3 and then also 2 will get deleted, you will have a sorted array here. Okay. So, this is the logic of heap sort technique, right.